Anyone pending? Hello,
Yes,
So which
sir.
group?
you can hear me? I have basically made a group for y'all, all of y'all on WhatsApp. You're all into it.
What's the name of the group?
Hello,
CS.
CS.
SAS only.
Yeah. Yes.
Ah, okay, so everyone is there, right? There's no one else pending, na, to be added on that group.
People who are absent are not added because they are not responding.
Okay. Vinci is not there in that group. Kindly add Vinci. Vinci, send them your number. They'll add you in the group. Okay, if who is not there, please send the numbers. Okay.
So Shubham and Pradeep had sent the request, invite request, but some people don't respond to it. So what can we do with that?
You can just add them no in the group. In
No, sir.
WhatsApp, you only have to know their number.
Yes, sir.
Mobile
But
number only required to know, no?
yes, sir. No, but some people do request only. No, means we have to send request only. Then only they accept the request if they want to come in the group. They can't be forcefully added.
Okay, if they are not accepting, then leave it. But you tell them that this has told.
Oh,
Okay.
yeah.
But otherwise, you add the numbers from the mobile phone. Then, if they want to accept, if they have kept their privacy settings in like that, that is their problem.
Yes, sir.
Okay.
That is what is
But
happening. We have sent the request to everyone.
okay. Right now, Vinci you add in, and one more guy is there who just now messaged me. Roll number 8. Okay. So please send Harsha or Tausif your number, and they will add you. In case they don't, then you can send a number to me. You'll know my mobile number. I will add you again. Okay, so don't worry about that.
Yes, sir.
All right, now coming back. Okay, so last time I gave you the list of experiments, guys. You all are there.
Yes, sir.
I'd given you all the list of experiments, right? EDC.
Yeah.
Okay. So the first one is filters, transistor DC biasing, RC coupled, all that. Class A, Class B. Okay, for EDC. So today we'll directly go in virtual labs. I hope you all come on your laptops. Guys, please be on your laptops.
Yes,
Because
sir.
right now we have to go in IIT Mumbai. Virtual labs of IIT Mumbai. Okay, and please use a proxy. I will share my screen right now with you all. Okay, my camera is creating a bit of a problem because if I put a camera on, it's not working that good. I'll sharing my tab with you all. You can see, guys. Please let me know. You can see the tab.
No, sir.
No, sir.
No, it's taking some time.
Now we can see.
Tab has come.
Yeah.
It's come. You all can see the tab, right?
Yes, sir.
Okay. You can see the Google page, no?
Yes, sir. We can
Done.
see.
In case it goes off, please tell me. Yes. So your first experiment which we have to perform is on filters. Okay, so the first experiment which we're going to perform is basically on filters. So what you do is always remember, don't go on that IIT VLab site and start searching from there. It will become basically a very tedious process. Just type filters and write VLabs. Okay. So here we got active filters, virtual labs. What do you mean to say by passive filters? What do you mean to say by passive filters, guys? Active and passive. Passive is your hardcore component. Hear me, right? Hello?
Hello, sir. Your voice is breaking a little bit.
Yes, sir, we can hear you.
Okay. All right. So we'll go for the virtual labs. Okay. So when you click on that link, you will directly get this. You can see this link, right? Virtual labs. Okay. So
Yes,
we
sir.
have active filters. So your aim, theory, yes. So your aim, theory, everything is basically given here. Okay. So we'll go for the theory part. First, we'll understand what does the theory comprise of. It's taking time to load. Okay. So we got the theory here. Now you can even download this theory, whatever is here. Okay. The download button is basically here. So to make your files and all, your theory, everything is here. Everyone clear? You can just copy this, select, copy it, and paste it in your Word document. Okay, so for every this thing, we are going to make a PDF. Everyone clear?
Yes, sir.
Hello? Hello? Yeah. So we'll basically split up the experiments in the group, how we did it last time for DSD. So one person does one experiment. Does one experiment meaning does the write up. Okay, and then all of you all can merge it together. Experiments, all of you all are going to do it here. Okay, but for the write up part, you all can all combine it into one. So this becomes good for you all also, and we'll make a small PDF copy and keep. So everyone will have one PDF copy. You all have to submit to me in Word. Okay, same thing what I have told for this thing as well for the other practical which I'm taking for. Okay, that is DSD. Okay, same thing for this as well. 1 minute. Okay. So you have your active filters, which is here. So we have two types of active filters. Okay, one is the low pass filter, and one is the high pass filter. And then there's something known as wide band pass filter. Okay, which is somewhat the intermediate. Okay, so this is your full theory. Once we basically go to module 1, module 2, we basically we can go in detail with it, because we're going to learn this anyways in a. So we'll be basically dealing with the low pass and the high pass filter. Band pass is not required, it's not in our syllabus. So, tutorial. What is this? Simulator. Okay, it is not loading the net list. Okay, there's something wrong. You should actually open it right now. Spice. You all can see this, guys, all of you all?
Yes, sir. Yes.
Hello? The thing is actually to perform the experiment, okay, you have to go on simulator and click. And when you go on simulator, you have to click on low pass filter, and then this thing opens up here. Okay, but somehow the
No, that's not
IIT
okay.
website is not opening up
No,
this
sir. Here
experiment.
also it's not
I
okay.
think maybe they are doing.
For us also it's not okay.
Yeah, that's what. It's something wrong with the server of V Labs, IIT V.
Yeah.
Okay, because when you click on this, it opens up here. Okay, it's not opening up, so there's something wrong. Maybe they're doing some testing or whatever. I'm not sure, but it is not opening up. Okay, but we'll just go to the theory. Today we may have to go for the theory. It's the same type what is going to be incorporated there. We have the low pass filter. So in the low pass filter, okay, this is basically known as your amplifier. Okay, so we still have capacitors, resistors also, but this is basically an amplifier which is used here so as to filter out whatever ripples or whatever unwanted signals are there, so as to get a pure waveform. So active filters involve the use of operational amplifiers. This is basically your operational amplifier along with resistors and capacitors, because you have to have resistors and capacitors so as to maintain uh, the steady state working of this operational amplifier as well. So you require your resistors and capacitors also to be connected in this config. These filters provide a similar response to LRC filters without using inductors, which make them later blah blah blah. Okay, this is no problem. So for a low pass filter, okay, what will be its values? Okay.
So what is low pass
So the
filter?
transfer function is as follows. V0 is what?
What is exactly low
Okay.
pass?
When you basically say low pass filter, okay. So basically when you say low pass filter, okay, it basically passes all the, it is basically like a cutoff. Hello?
Yes, sir.
Hello?
Yes, sir.
Yeah, it is basically like a cutoff. So anything higher, any value higher, say, for example, um, say you want at the output, okay, 5 volts, for example. Say you wanted the output 5 volts, okay, and say your input signals which are coming from your input side, your V in, okay, is basically say 10, okay. So it will, but you basically want only 5 and below, not above. So which are whatever signals are falling in between 0 to 5, you will get it. So you have a low pass filter. When you say it's a high pass filter, any values above 5 that it will give you. So that is basically known as a high pass. And then when you say it is a, let's come down. And when you say it is a band pass filter, it is in between. Say in between 5 and 10. Okay, so any signals in between 5 or 10, it will allow it to pass. Rather than that, Above 10 or below 5, it will not allow to pass. What this?
Yes, sir.
Hello,
It's like a
can you hear me?
7805 IC. Does it contain low pass filter?
Yes. 7805. I will have to check that IC out. There are
No,
various
actually,
ICs
that
available
IC, if
too.
you give more than
Okay. But I will
above,
have to
if you
check that.
give above 5 volt, it will give you output of 5 volt. 5 volt to 34 volt, 6 volt to 34 volt, it will give you output of 5 volt. That means it contains low pass filter.
Sorry. Just tell
Uh,
me again.
so that IC is
Sorry,
used
just tell me
exactly.
again
So
what you're
that
saying.
IC is used to get 5 volt,
What is the IC number? Just tell me the IC number
7805.
again. 7805 is a regulator,
Yeah,
no? That is a 5 volt
5 volt
regulator.
regulator.
It is a regulator. Don't, yeah. See, if you're talking about, it could be considered as an amplifier as well, because it cuts off at 5 volts. So it could be called as a low pass filter, but that is basically a regulator. That will regulate it to 5 volts. It will not, see, low pass filter is what? It will allow any signal between 0 to 5. Here it is regulating the 5 volt. That means if your input voltage is 4 volts, if your input voltage is 4 volts at the output, you will get 5 volts. It will regulate it to 5. But still, that is if you have appropriate capacitors also connected, so as to discharge when that shortage is there for a while. Okay, and say if in the input you get a 10 volts and you put that regulator is what to convert from 12 volts to 5 volts. So if the input you have 12 volts, it will step down that 12 volts and make it 5 volts for you at the output. This is Tosif, right, asking me this, if I'm not
Yes,
mistaken.
sir, yes, sir. Got it.
Yeah, you understood, right? So that is a regulator. So don't get confused between a regulator and a filter. Okay, filter is what? Okay, so as to filter out all the ripples. Regulator is for what? If you're getting, it is basically like an adapter. Say you connect it to a 230 volt supply and you're getting a 5 volt output. Okay, so
Okay.
it is something like that. It is your no matter what voltage is there at the input, it may be 12 volt, it may be 20 volt, but it will convert that 20 volt to a regulated 5 volt supply at the output. You understood, Tosif? In the same way, you have it is called IC7805. The same way you have IC7812 also, which gives you
Yes.
12 volts.
Yes, 1, 2.
Okay.
24.
Yes.
Got it.
So, yeah, I don't know how many faculties you would be able to say about 7812 and 7805. But anyways, since you're already designing this, you will know this. Okay, 7805 and 7812. Like that, there are even for others. And they have a tolerance limit. That doesn't mean they are not tolerant. You cannot give a 120 volt DC supply at the input and expect it to give it 5 volt. It will burn off. So
Yes,
they
sir.
have their thing also. So I think if I'm not mistaken, for 7805, the maximum voltage which cannot be exceeded, okay, is maybe around some 40 volts roughly, 40 or
The
45
25 to
volts.
35
Okay,
something.
25 to 35. It depends upon which manufacturer it is. That
Yeah.
also is a,
That also matters.
okay. You tell me what is not there, I'll tell you. Okay, and that's how the price cut is also there. Okay, that's how Chinese manufacturers make. Okay, now this is going into another topic. Let's come back to the main topic. Okay, so anyways, you all got what I mean to say by an high pass filter, low pass filter, and band pass filter, what it is. So whatever is at the input, you will get it at the output within that range. So in that range, you will basically get your. So we have a high pass, low pass, and a band pass filter. The equations and all, we will do it when we basically open this topic in class. Okay, but as of now, okay, you all can just go through this. All of you all are on your laptops, everyone.
Yes, sir.
Everyone are all okay. Everyone has their laptops. No, good. So just go through this one time. Okay. See, cut up frequency.
So is this used in audio circuits?
Yeah, obviously. The signal, the useful signal without the noise and without the ripples in the background. It is part of it is used in audio amplifiers. All these filters are definitely used in audio amplifiers. So what you all can do is you all only write till this much, okay? Till wide band pass filter. This is basically not required. Even band pass filter is not there for y'all, but y'all write only till band pass filter. This y'all leave. Okay. So y'all can start pushing out inward simultaneously right now only. Okay. Y'all can do it together. Y'all can do it as a team. Y'all can do it single. Y'all can allot. However y'all do it, but y'all have to do it and then submit it. As of now, see the simulator is not working here. I don't know why. Today we were supposed to conduct filters. I don't know when it will be up. If it's not up, then we'll keep it as a study experiment. But still, what we will do is in the observation table, we'll at least draw that and keep it ready. It's not working out here. You can go in one thing. You can go in additional resources, or you can download a software known as PSpice. Okay, if you download that software PSpice, you will get all the components and you can align the components and you can run it. However, if this does come up, download the netlist. You can click on this low pass filter. I think I better put my proxies. Working without the proxy. You can see this, guys. Wait, I'll just share that screen. You all can hear me, all of y'all.
Yes, sir.
Yes, sir.
Okay, I'll just share the screen. Huh? Okay. So when you basically, okay, you will be taken to this screen. Okay, you'll be taken to this screen. So you got the full program here. You can vary the values, change the values here only, and it will run the simulation. Okay, I don't feel there is any use of this because till you don't do it on the breadboard, there is no use. But for time being, something better than nothing. So this is your program. So this program also you have to take a printout of. Okay, and you have to write there. It is performed in this virtual labs, and you basically got these values. So you can manipulate the values here. So all these values, whatever are there, actually come in this simulator. And you have to click here load the program here and press run, and then it will tell you the values, and those values you have to note down and see whether these values, these practical values what we get, actually match our theoretical values what are there in the theory. So as of now, y'all, one of y'all, who wants to take up this experiment to write, I mean to basically make it in a Word document. You'll all want PDF copies, right? Hello,
Yes, sir.
hello. You'll all want in PDFs, na?
Yeah.
Meaning in Word documents. Okay. So one of y'all can now take up the charge of doing, meaning writing all this write up, putting it in a Word document. Okay. Or all of y'all can distribute the work. It's up to y'all. But at the end of the day, I want the experiment 1, which is done. Y'all want me to allot y'all?
Yes, sir. A lot.
Hello. Allot, no?
Yeah.
Okay. The previous ones are already allotted that you all have, na? Who is given what?
Yes, sir. So I have messaged you
Harsha,
on the
Tausif,
group.
Pradeep, Rupam, Shubham.
I have
Sorry?
messaged you on the group.
Okay. I don't know if that could be possible. Okay, 1 minute. Okay. And if you all are basically coming to Shiroda, you all can take that file from me as well. No big deal. Okay. Now, coming back. So like this, you have to go to the additional sources, click on additional sources, and even download for high pass filter and band pass filter as well. So now we are going to see for band pass filter. So this is for band pass filter. So you can change the values here, okay, of the DC from 3 to 15 volts, from 4 to 15 volts. All these values of the resistors you can change here. So you can put here 1000K, 10K. So you can vary all these values here. And then you have to run the program. It will tell you the direct output. Basically, you don't have to do anything. You have to just change the values here and get whatever output you want. So both these programs, okay, all these 3 programs have to be copied from me. Okay, so time for allotment. Filters, Harsha, you're okay to do?
Yes, sir.
Okay. Then totally 8 experiments we have to do. See, the last one, no, last one is FAT. That is transistor DC biasing. Okay. For Pradeep. So Pradeep is going to do transistor DC biasing, RC coupled TOSIF, RC coupled is TOSIF, huh? And transistor DC biasing, Pradeep. Transformer coupled. Who else is there? Rupam.
Yes, sir.
Okay, Rupam, transformer coupled. That experiment you are doing. The write up of that. Okay. Then Shubham, Darlington pair.
Okay, sir.
Shubham is doing Darlington pair. Who else is remaining? Who else is remaining, guys?
Sir, Vinci.
Vinci. I think Vinci is where? Yeah, there he is. There. So Vinci can do. So Class A. Vinci. 6th experiment. I have Class A, Class B. Class B. One, two, three, 6. Well, then we have push-pull amplifiers. Aksha?
Yes, sir.
I'm giving you one more extra one, okay? Eight experiment. That is push-pull amplifiers.
So write it and submit on the group.
Yeah, I'm doing that only.
Okay, sir.
So one extra one you have, no? I'm telling you that you have one more extra.
Okay,
TOSIF, I'm also giving you one extra. Voltage series, voltage shunt. TOSIF, you're there?
Yes, sir.
Okay. It is already there on the IIT, this thing, VLabs website. Okay, so all the theory, everything is there, only that you have to copy paste it and put it in Word.
So,
Right.
what is the next one? Voltage series.
Voltage series, I'll be sending it in the group. TOSIF.
Okay, sir.
Okay, with your names.
Okay.
So totally now we'll have 1, 2, 3, 4, 5, 6, 7, 8. 8 experiments we'll have. And Shubham will have one extra experiment. That is RC and LC oscillator. Okay, Shubham is there. Shubham,
Yes, sir. Yes, sir. I got it.
yeah, RC and LC oscillator, one extra you will have. Okay, so this is how we can do. See, you all can all work as a team also. Okay, I have no problem as long as it is completed. Okay, so one can submit and then I'll compile everything in one and I'll give it to you all, wherein you all can add your values and then you all can revert that same back mail to me. So in this way, the full file will be done and it will be done in a digital format. So you all will not waste time and write simply unnecessarily. Okay? Simply writing and just copying blindly makes no sense. Performing the experiment makes more sense. Okay, I'll send this in the group to you. Please add the people who are not in the group. Okay. Okay, it is sent. And I'm even sending for DST. What is has to be done? Please check one time and confirm. Okay, everyone got it? Everyone got? Guys, in the group? Okay.
Yes, sir.
All right. For now, you'll start this thing, copying it into Word. Okay. And the other people who have the other experiments also start doing it. Today, filters can't be done because of it's not put up on virtual labs, but you all can start with your other experiments, writing the write-up. Okay. I'll just show you all one more time. Say now there is another experiment. Okay, say transistor DC biasing. So what you do, just go on Google search, type DC biasing and click on VLabs. Put a dash and put VLabs, always remember. See, VLabs has it. Okay, so VLabs doesn't have it, but there is already an experiment out there, so you can just check. Guys, you all can see my screen. You can see my screen, right?
No,
No,
sir.
sir.
No, sir.
The screen went off.
Okay, now just tell me when it comes on, okay? Came on?
No.
What's wrong with this? Wrong. Let's go find us. Tell me when it comes. Huh? You can see it.
Yes, sir.
You all can see it now? Okay. So say now the second experiment. What is the second experiment? Transistor DC bias. Okay, and put a dash and write V labs. Time to load. You can see this transistor DC biasing VLAN, the Google screen. Guys, hello,
Yes, sir.
hello. You can see the screen. Yeah, you can see the
Yeah, we
screen,
can see
right?
the screen.
Okay. So type transistor DC biasing like this. Taking times to load because of the net connection. I'll just see if I can put a proxy. Guys, you can hear me? Sorry, net connection. Today the net is really having a problem. Hello, guys, you can hear
Yes,
me?
sir, we can hear you.
Yeah, today the net there is some problem. I don't know what's wrong. Today it is really slow. Share a Chrome tab. You can
Yes,
see
sir.
my screen, guys. Okay. So click on this. I don't know if it hangs again. Okay, because it's taking some time. Again, it's also not working. Okay. Anyways, this is the way of going into. Okay, just type VLab. You will get a list of experiments. Even if it's not dealing with VLab, okay, you will get some other PDFs. So you can write your AM theory procedure from there also. There's no problem. Okay. But all of you all have to follow the same pattern. Whatever you all choose. So here you have experiment 2, transistor DC biasing circuits. So you can copy the theory from there. And in the same way, you have to mimic your observation table as well. If it's available on PLab, well and good. If it's not available, we'll have to do it in this way. So I think PSpice is free for everyone. Okay, if you all can download that software, you could perform some things on PSpice and get it done. Like that, you can even use PCB making softwares also like EagleCAD, and but you'll not be able to do simulation. PSpice will be able to do simulation. It will only give you PCB layout. So see, we have transistor DC biasing circuit here. Emitter bias. Okay, and the voltage divider bias circuit. This is what we have done in the first year. Okay, so the full theory is basically in this. So you can just copy it like this. Going back to filters.
Yes, sir.
Yeah. So you all
Yeah.
do that stuff. If anything is there, you'll just let me know. Anything is there, just message me or tell me in the conference. I'm here again. Download everything and paste now. Okay, guys, go for your roll call. Hello.
Yes, sir.
Yeah. Go for the roll call. We'll
Okay,
go for
sir.
the roll call. Okay. Tosif present. Ajay
Present.
01. Ajay is Ajay 01 absent no. Tosif 03
Present, sir.
Jadav. Yes. Harsha 05 05 05. Pradeep. Pradeep is there with us. Absent. Okay, Pradeep absent. 06 Rupam
Present, sir.
present. Yes. 08
Present, sir.
present. Yes. 09 Shubham. Shubham. Shubham is there, no? Yes. Vinci 10
Present, sir.
present. Yatin 11. Roll number 11. Yatin absent. Okay. So Yatin is absent. Roll number 11 and roll number 1 and roll number 5. Pradeep. 3 are absent. Guys, ask me if there's any problem. Just compile it. You can even reply me in the group. Okay.
So I can't copy the figure.
And then in the same way, band pass filter.
So hello.
Hello?
Hello, sir.
Guys?
Yeah.
I think we can wind up now. It's already time up.
Okay, sir.
Okay. Just follow the same file procedure, how it is.
Okay, sir.
Okay. I'll send you all the sample copy. I sent you all how it is.
Yeah.
I sent you all, I think, no? Oh, yeah. Do it as per that only.
Okay, sir.
Okay. Okay. Chalo, guys. Yeah. Yeah. Bye. Bye.
Thank you, sir.
Thank you. Thank you.